Disclaimer. This video tutorial is for training and information purposes only. The techniques and recommendations presented in this video are based on general best practices and experience. Please note that individual circumstances, such as specific company policies or industry-specific requirements, cannot be addressed in detail. The information contained in the video is not a guarantee of success in the subject matter and does not replace the need for individual preparation and practice. The content reflects the opinions and experience of the creator and makes no claim to completeness or accuracy in all situations. The creator accepts no liability for any direct or indirect loss, damage or inconvenience that may arise from the application of the content presented in the video. For detailed advice or special requests, please contact us at contact@experts4excellence.com. All content shown in this video is protected by copyright. Any reproduction or distribution is only permitted with our written authorization.
Welcome to the course Basics of Lean Management. This whole training will take approximately 2 hours. It contains short breaks for your reflection and relaxation. And now, have fun with the basics of lean management. And this is our program today. Before we can go into the principles of lean management, we must first understand the concepts of push and pull in value chains. After that, we will look at the basic concepts of lean management, which will then lead us into lean manufacturing and the continuous improvement processes. In between every block we will have a short reflection in order to recap what we have just learned. You can suspend the movie at any time you like and resume whenever you are ready for it. Okay, so let's get started with push and pull and the very important decoupling point. The two basic production control methods are push and pull. Push is when you produce something against a forecast and into stock. Pull is when you produce only when you have a customer order for it. The point where push turns into pull is called the decoupling point. Based on the product and process characteristics, the optimal operations model is defined with the aim of minimizing manufacturing costs and increasing customer satisfaction. Let's have a closer look at the push model first. Push processes are based on forecasting and planning. Management and planning of these processes is complex because all activities must be coordinated with planning and internal orders. And this leads to long preparation phases due to elaborate planning, long reaction times to market changes, huge uncertainty due to long reaction times, an overall slower throughput time, which promotes the bullwhip effect, but also the shortest overall delivery time to the customer for standardized products. Sit back for a moment and think about whether you know a case of a pure push supply chain or process. Here are a few examples. Electric power supply. Whenever you plug a device into the socket, the power is already there. Water supply is the same. Food, when you go to the store, food is in the shelves. Now let's look at the pull model. Pull processes are demand-driven, triggered by the customer order. The information flow in internal processes as well as with external partners takes place as early as possible. The coordination of the linked processes takes place as a customer-supplier relationship. This leads to longer delivery times to the customer, compared to the push process, a reduction in the total cost of stocks and a reduction in non-value-added activities in production. On the other hand, it is difficult to reduce throughput times and thus delivery times to the customer. To achieve economies of scale, since there are hardly any possibilities for foresighted planning. Now let's do the same thing again and think about whether you know a case of a pure pull supply chain or process. Here is an example. Construction business. Building a house will only be started when there is a customer order. What else can you think of? Think about the automotive industries. Push and pull. Most value chains, however, are combinations of push and pull. It combines the advantages of both systems. Typically, the initial part of a production in which generic semi-finished products are produced is push-based. The interface between push and pull is called the decoupling point. Here one system turns into the other. The decoupling point is often realized by a first-in first-out buffer. The final assembly is typically pull-based. The decoupling point is a very important point, as it determines the performance of the supply chain and the commercial success of a product or service. The decoupling point should be set very consciously when designing a supply chain. It should never be the result of a sourcing strategy. But it is always a trade-off between inventory and customer waiting time. Let's have a look at a simplified supply chain. When a customer places an order with a company, the company starts the sourcing process with its suppliers for those components that are not standard and that are needed to fulfill the order. Upon receipt of those components or raw materials, the manufacturing process starts. When the product is finished, it is shipped to the customer. Somewhere in the manufacturing process sits the decoupling point that separates the standard components sourced against forecast in the push mode from the customer order specific parts that are only sourced upon the receipt of an order. That is the pull part. What you see here is the real value chain of a mobile phone. The decoupling point was set on purpose between level 2 and level 3 manufacturing. This allows short delivery times when there is a customer order. On the other hand, there is a significant amount of half-finished inventories sitting in the shelves and waiting to be processed. Think about what would change if the DCP would either be moved further to the right or would be moved to the left. The left side of the DCP represents the inventory of half-finished goods you have to keep, while the right side of the DCP represents the customer waiting time. So, if you move the DCP to the left, you reduce your inventories but increase the customer waiting time. If you move the DCP to the right, you shorten the customer waiting time on the expense of increased inventories. So, let's summarize push and pull. In push systems, production decisions are based on long-term forecast. This is also called build to stock. The key properties of push systems are excessive inventories due to the need for large safety stocks, larger and more variable-sized production batches, standardized products, not customized, inventory obsolescence, short lead times if products in stock, long lead times if changing demand pattern. Emergency production situations increase cost. In pull systems, production is demand-driven based on real customer orders. This is called build-to-order. The key properties of pull systems are: information must flow fast across the overall supply chain, production and distribution systems must be adaptive and flexible with higher skilled people. Short lead times for changing demand patterns. Decreased inventory in the supply chain, only raw materials exist at the decoupling point. Decreased variability in the system. Higher customization levels. Economy of scale might be not achieved. If lead times are too long, a push-pull system is needed. A few terms need to be clarified. Build-to-order, BTO, means that the production process is not started until a sales order has been received. This is the counterpart to build-to-stock or BTS example, automotive industry. Build-to-stock means that parts or products are produced against forecast on stock. This is the counterpart to BTO. Example, food industry. Build-to-print means that a product, often a one-off product, is manufactured on the basis of a plan or design. Example, real estate, shipbuilding, special machinery. Configure-to-order means that generic versions of a product are produced on stock and configured according to customer specifications only after receipt of an order. Example, B2B software. And finally, let's look at some methods that must be applied on push and pull systems. In push systems, material, capacity and production needs to be planned ahead. The forecast is the control instrument, and the method is lead time scheduling. In pull systems, only material and capacity needs to be planned, while the production sequence is determined by the receipt of customer orders. The customer order is the control instrument. Methods used are Kanban, just-in-time or just-in-sequence. In combined push-pull systems, the combination of both is required. With that, we have successfully completed the first chapter in this module. Please take a moment and think about what your 3 key learnings were in this chapter. Write them down. Ask yourself if you can use these lessons learned in your daily work. And if so, how? Now reward yourself and take a short break.